Okay, so now we're going to start looking at doing some calculations with momentum. And so once again, just to get it out on paper, momentum is mass times velocity. And so we're going to say little p equals mv. And so it is going to, and the units on that are going to be kilogram meter per second. Okay, but as I said, what we really want to talk about is collisions between two objects. And in this case, we're going to have our little carts. And so what we're going to do is we're going to call this object 1 and call this object 2. And the big equation that we're going to work with is we're going to say that the momentum of object 1, the initial momentum of object 1 plus the initial momentum of object 2 is going to equal the final momentum of object 1 plus the final momentum of object 2. So if I take the two initial momenta and add them together, it's going to equal the two final momenta added together. So the total momentum before the collision is equal to the total momentum after the collision. Now that leads us to kind of an equation that people think is pretty awful, which is I sort of break these out, and so I say m1 v1I plus m2 v2I is equal to m1 v2f, v1f plus m2 v2f. Let me check that. m1 v1I plus m2 v2I equals m1 v1f plus m2 v2f. Okay, so now we're going to start off, and the first thing that we're going to talk about is inelastic collisions. And in an inelastic collision, the objects stick together. After the collision. Alright, so let's just come up with some examples. First off, we're going to say m1 v1I v1f m2 v2I v2f, and we're going to say that we had one cart, and the one cart had a mass of 0.75 kilograms, and we'll say it had an initial velocity of 1.3 meters per second, and we're going to calculate that in a second. And we know that m2 had a mass of 0.25 kilograms. And let's start off for our first example. Let's make it very easy. Let's say that the initial velocity of cart number 2 was 0 meters per second, and then we're going to figure this out. Now, the key thing that we know is because the objects stick together after the collision, then we know that they have the same velocity after the collision. So we're starting off with sort of the simplest we can go, and then we'll work more complicated from there. So because they have the same velocity after the collision, we are going to just call that just straight up v, without any subscripts on it whatsoever. So I plug this into my equation, and I get 0.75 kilograms I'm going to drop it down a line so I don't run into that. 0.75 kilograms times 1.3 meters per second plus 0.25 kilograms times 0 meters per second is equal to 0.75 kilograms times this unknown V plus 0.25 kilograms times this same unknown V. Okay, so what I can do is I can say this whole left side here is going to be 0.75 times 1.3. That's going to be 0.975 kilogram meters per second. And then my whole right side here is going to be 1 kilogram times V. Now solve that for V, and I get, well, I just divide by 1, so I get 0.975 meters per second, or we'll call that approximately 1 meter per second, roughly. Okay, so then let's see if we can do another one of these in the next couple of minutes. Let's say we have an object that's 3 kilograms going this way at 2 meters per second. And we have another object. We'll call it 2 kilograms moving this way at 4 meters per second. And so I start off and I go M1, V1I, V1F, M2, V2I, V2F, and again it's going to be inelastic, so they're going to stick together, so those two are going to be the same. This is going to be 3 kilograms, this is going to be 2 meters per second, this is going to be 2 kilograms, this is going to be 4 meters per second. But now we run into an issue. We have to express the fact that the two velocities are in different directions. So how do I do that? Well, I can either make 2 meters per second, or I can negative, or I can make 4 meters per second negative. I'm going to say positive is to the right, negative is to the left, so I'm going to say that my initial velocity of V2 is going to be negative 4 meters per second. So now I have, just going through this really quick, I'm going to go 3 kilograms times 2 meters per second plus 2 kilograms times negative 4 meters per second is going to equal 3 kilograms times V plus 2 kilograms times V. And so if I do this out, I'm going to get 6 minus 8, I'm going to get negative 2 kilogram meters per second is equal to 5 kilograms times V. And so V is going to be negative 2/5 meters per second. And that's going to be negative 0.4 meters per second. So the result of that collision, 3 kilograms moving to the right at 2 meters per second and 2 kilograms moving to the left at 4 meters per second, overall the two objects, when they stick together, are going to move to the left at 0.4 meters per second. That's that lecture.